Okay, so let's get started with Android Room. This is the main how to get started guide for Android Room. It starts off by explaining the advantages, why you would want to use this particular ORM. We'll find out about these advantages soon enough. So let's dive right into it, the setup. The first thing we'll need to do is to include a dependency on the library within our build.gradle file. The first one is actually a library dependency, so it adds some code to your application that will be shipped to the devices. The other one is an annotation processor, which is a piece of code that runs at compile time. So it scans your source code, and based on your source code, it generates some more source code automatically, like magic. The other dependencies listed here are optional, and we won't be using them. So I'll just copy paste this bit here to a new Android application into the build.gradle file, and I'll just put them here like that. And I say sync now, and it will download the library, install them, do some scanning, and eventually, it's done already. We should be able to use it. Okay, so what's the next step? It's usually the easiest to start by creating your data models. I like to create data models in a separate package to keep the root directory a little bit clean. Let's name it models. There are other ways to organize your code as well, of course. And then within the models directory package, I create a new Java class. And let's say we'll be modeling houses. So imagine we're creating an Android application that allows you to see what houses are for sale, how big they are, how much they are supposed to cost. So one model entity will of course be a house. Alright, so what's in a house? We'll keep it really simple for now. This is just a Java class, and I'll make all of the and I'll use it as a data class, which means I'll just make all of the properties, the instance variables. I'll make them publicly available to read and write. Of course, when your application gets bigger, you can and you should use getters and setters, but we'll not do that for now to keep things simple. So a house probably has a street address, which we can split in two parts. So that's a street name, and then there is a house number. At least it's like that in this part of the world. And there's probably a city and all that kind of stuff. But let's not worry about that. That's just boring. And then of course there is the asking price for the house. And then there is the size in square meters or something like that. Doesn't really matter. It's just generating a couple of fields to play with later on. These fields can be more complicated, but for now we'll stick to the basic types. Now this is just a regular Java class. There's nothing special here. The special stuff starts now because we're adding an annotation called entity. And as you can see, it's already suggesting to use the Android X room entity class annotation, which is the one we want. And basically, that's most of what we need to do to convert our plain old Java class to a ORM class in Room. The only thing that's missing is an ID. Databases really like to assign IDs to rows, and Room is not an exception. So the IDs in Room are preferably long integers, so just long, and I'll call it ID. And then I need to add an annotation here, primary key. There, that's it. There are a lot of other options and extra annotations we can do to provide Room with a lot more instructions. But for now, this is fine. That's part one. Next thing we'll need to do is to create a DAO. So what's the DAO? let's start following this tutorial a bit. A data access object. So we have the rest of the application, and from the rest of the application we're interacting with the data access objects. There can be multiple, but for a simple application it will only be one. And we're asking the DAO to do a query for us. So the DAO actually contains the queries, and it usually returns entities in response. Or in case we're doing update queries, we can also provide it with entities, so data model entities, and it will save them to the database. And the entities are the things we've just seen, the house. Alright, so this is the entity. No, this is exactly what we did. We created the long, which I think is better. Then, next up is the DAO. I think in this case there will only be one DAO, but even so let's call it house DAO. So this will contain all kinds of queries that are related to something with the house model. I've made it an interface, that's what it says here, and I'll add an annotation DAO to make it specifically a room DAO interface. And within this interface, as you can see here, we can define queries. So now suppose we want to define a function that just returns the list of all houses. And that's pretty easy to do. What we need to do is, well, first create the function. So what will this function return? Well, a list of houses, like that. Yes, that's the one. Oh, and we need to import list as well. There it is. And let's just name it get all houses. Of course, usually when you define an actual implementation in a class, this is where the implementation would go. But that's not what we're doing here, because this is an interface and the actual implementation will be taken care of by the room compile time magic. And we need to let room know what this query should actually do by means of an annotation. The query annotation, and within an argument to the query annotation, we can just pass an SQL query. And that's one of the nice things about room. It doesn't insulate us from the database that is beneath SQLite. We can actually just use our knowledge, apply it over here by typing SQLite queries. So select star from house. And what's interesting here is that it can actually do autocomplete, Android Studio can, based on the entity we just defined. So it knows that house is now a table within this database. So that's awesome. It also allows Android Studio to do live checking of your queries. So when I type house X, which is a table that doesn't exist, it will immediately start complaining. Same as when I try to select a field that doesn't exist, it starts complaining. When I say street name, oh, there you go, it's happy. So that's actually really cool, and it allows you to prevent a lot of runtime errors. And this is basically all that's needed. This gets compiled into a class that has a getAllHouses method, and that method well, returns the list of houses. So how do I actually run this method? How do I instantiate such a house DAO interface? You cannot just instantiate an interface, of course. There's another thing that's needed here. The guide explains it. We need a database class. So let's create that, and we'll call it app database. It seems like a sensible name. We'll just do that. We'll create a new Java class app database. There, yes, add it, and from there we'll just paste it in. All right, we need to import some modules. There it is. Our DAO is called a bit differently. House DAO. house DAO there. And right, and at this point we need a list of entities. So we're defining all of our database here, and the database class needs to be aware of all of the entities that are should be part of the database. So in this case we've created an entity called house. So we need to let the database class know that we want to include the house within this database. If there would be more than one entity, we could of course add them as such. There's a version mentioned over here. This is for database migrations. We'll get to that later. And what this does, this is also a method that will be automatically provided to us by a piece of compile time magic from Room, and it will instantiate a house DAO. So it will automatically create the implementations for the interface we defined and create an actual object that fulfills that interface. And that's all we need to do for now. So now we should be able to interact with our database. Only thing is we need to create an instance of this app database, and that might be a bit difficult because it's an abstract class and it contains an abstract method. So we cannot directly instantiate it. There is a piece of magic involved here as well. The magic is like this. We need to use a Room database builder. So let's just copy paste that. And for now, I'll do that within the main activity. In the onCreate, I'll just create an instance of our database. Okay, the name matches. This is for debugging. All right, that's cool. The app database has a single method that we're interested in, and that is the house DAO method, which will instantiate a house DAO object for us. And on that object, well, we can do our query, get all houses. Wow, okay. So what should this return? Well, it returns a list of house objects like that. Import it, please. Yes, and the list as well. Thank you. There. And this should get us the list of houses. Let's see if we can. Well, let's just list over them. So I'll create a loop. For house in houses like that, and then I want to do a print of each house just on the log. So I'll do a log debug like that, and let's for now just print the street address, the street name like that. In order to use the log d like that, we need to define the tag log t. There. Right now, this probably won't do anything. Why? Well, because the database is still empty. So let's add another query to house DAO. Want to insert something into the database. One way to do it is to write a query to do it. So that would be insert into, and then the fields will insert into, and then the values, and then we need to match parameters. And sure, that's one way to do it, but well, that takes a bit of typing. And Room saves us from that by having an annotation called insert. And what it does is it automatically generates all that I just talked about as code. So I can just say name this method add house, and as an argument it gets a house there, And this is basically all there is to it. So provided the house object, it will automatically insert this house into the database. It will generate a query that does that. Which means that we should be able to insert houses now as well. As we're using the DAO more than once now, I'll put it in a variable. So house DAO equals db house DAO. And let's first do an insert or an add house query. And then of course we need to be able to provide a house. Well, for an Android application that doesn't have a user interface yet, we're going to have to make something up. So we'll create a new house, and we're at least going to have to set the street name. And for now, I'll just set it to something familiar, right? That's the only one we're actually going to be interacting with for now. So let's keep it to this something boring. So if everything works correctly, and we're recycling the house variable here, so it's complaining a bit about that. So we could either remove the declaration here or have it. Oh, it's not happy about that. No. So we can put this in the scope like that. All right, everybody's happy now. Let's try to compile and run this application. And what should happen is that the first time we run this, we see a single Van Galenstraat, and the second time we should see 2. Okay, there's a problem here. Why is that? Ah, right. So because house is actually in a different package, it is in a models package, which is different from the DAO. Fields need to be public in order for the DAO to directly access them. There. Alright, so it compiled successfully and it crashed already. Alright, let's see what happened. Nothing here. That's a lot of debug output. Yes, so there's the error. Let's make some room. Cannot access database on the main thread since it may potentially lock the UI for a long period of time. Aha, and that's why we learned about threading some time ago. So Android is basically telling us that what we're doing right here is not a nice thing to do. Why? A database query might take some time. Well, a simple query like this, provided there are not too many houses, would probably take under a millisecond and wouldn't be that bad. But the larger your database gets, and the worse your query is, the longer the query can last. And when you're doing this on the main thread, like we're doing here, this will freeze your user interface for your application. So even things like scrolling will start to block. The user won't be able to scroll for whatever the duration of your query is. That's not what we want. We want fluent user interfaces. So Android basically forbids you to even attempt to run your queries on this thread. Well, there is a way around it though. In the application builder, you can tell Room that for this time it's okay to allow main thread queries, and we'll do that for now. But we'll get back to that pretty shortly. So let's run it again, and let's see what the output is. May have to filter the output a bit. The application is running, but I'm not seeing any. Oh, there it is. onCreate Van Galenstraat. That's awesome. So let's test to see what happens when we close our application or just run it again. And it should now create 2 instances, but it doesn't. That's interesting. That's cool. So it says here that the unique constraint has failed. We're trying to insert another house, and this second house is getting the same ID. We're not actually setting the ID, so the ID is just the number 0. Because, well, that's just what the default value is in a Java class. What we could do is assign it a number in our own code, or we could have SQLite figure it out. So there's the auto-generate boolean for that, which we can pass as an argument to the primary key. This is generally what you want to do, unless there is some kind of primary key that actually makes sense in the real world. Otherwise, SQLite is the place, is the thing that should be generating these IDs. It's still not happy. Room cannot verify the data integrity. It looks like you've changed the schema, but forgot to update the version number. Yes, that's correct. You can simply fix this by increasing the version number. Alright, so I already warned you that we would be talking a bit about the version over here. It's telling us now that because we changed something to our database, we should also change the version number, so to version number 2. This doesn't quite fix the problem though. This will generate a different error, but an error still. And the error now is a migration from 1 to 2 was required but not found. Please provide a necessary migration path for blah blah blah. Okay, so what it wants us to do is to define a method here that executes all the database queries that are required to go from version 1 to version 2. Which is kind of a bit of work, and it's something you really should be doing for a production app, because well, that's the only way to tell the application how to safely convert from the one database schema to the other. But when you're doing development, that's not really nice to do, because you're probably iterating pretty quickly over database versions. So luckily there's a different way for development, and that is when creating the database using the database builder to say that it can fall back to destructive migrations. So what's a destructive migration? Well, it's basically what it sounds like. When there is no migration explicitly defined from version 1 to 2 in this case, it will just delete the database and create a new one, at least for the tables that have changed. So in this case, our earlier record of the Van Galenstraat will be deleted, database will be cleared, and it will start again for the first time. Okay, so that worked. Van Galenstraat is there once, and now I'll run it again. It's starting again, and as you can see, Van Galenstraat is there now twice. Phew, which means we're actually storing things in the database for now.